STRIATUS is the first 3D concrete printed bridge built entirely without reinforcement. Studio MLA will lead a major riverfront development in Riverside, California. Robotically wound flax fiber builds bio-inspired pavilion in Freiburg, Germany. SOM to design convertible, self-sufficient MILAN-CORTINA Olympic Village. GLASS-CLAD, triangular-shaped bicycle garage in Sweden is practical and sustainable. CASANOVA project of K-Render has been nominated for Best Rendering of the Year 2021. STRIATUS is the first 3D concrete printed bridge built entirely without reinforcement. STRIATUS is an arched, unreinforced masonry footbridge composed of 3D printed concrete blocks assembled without mortar, designed by ETH architects and engineers. ETH is a science, technology, engineering and mathematics university in the city of Zurich, Switzerland, in collaboration with Zaha Hadid Architects. Zaha Hadid, an international firm, the practice engages in creating transformative, cultural, corporate, residential and other spaces that work in synchronicity with their surroundings. It blends master builder approaches with cutting-edge computational design, engineering and robotic production technology. This study demonstrated how 3D printing can be utilized to create load-bearing concrete structures that require substantially less material and no steel reinforcement or mortar. Studio MLA has been selected by the California City of Riverside and its Parks, Recreation and Community Services Department to design the Riverside Gateway Project Suite. This project aims to revitalize the open spaces and trails along the northern edge of Riverside, the largest city in the Inland Empire region of California, with a population of over 300,000. To handle some phenomena caused by climate change, such as rising temperatures and other environmental hazards, the studio will develop its master plan as an opportunity to create access to water and recreation for citizens, while also designing solutions for stormwater mitigation, threatened habitat, and air quality impacts. Robotically wound flax fiber builds a bio-inspired pavilion in Freiburg, Germany. The first ever building with a load-bearing structure, constructed completely of robotically wound flax fiber, was created by a team of architects, engineers, and biologists from the universities of Freiburg and Stuttgart, constructed within the Botanic Garden of the University of Freiburg in Germany. The temporary pavilion is made up of 15 coreless components that are influenced by the natural structures. Each of these components is made of flax fiber that has been prepared. The flax fiber is robotically twisted into a complex truss structure with the corner reinforcement and structural bracing. SOM to design convertible, self-sufficient MILAN-CORTINA Olympic Village. Skidmore, Owings and Merrill was selected to design the Olympic Village for the 2026 MILAN-CORTINA Olympics, following an international competition of 71 architecture studios from 9 different countries. The project is part of the updated Porta Romana Railway Yard Master Plan and will create a new centre of activity in Porta Romana with minimal environmental impact. The self-sufficient project will feature residential, commercial and public spaces that change configurations based on the Olympics event. GLASS-CLAD triangular-shaped bicycle garage in Sweden is practical and sustainable. Tangbom Architects designed a bicycle garage situated next to the central station in Uppsala, Sweden, which can store 1,200 vehicles inside its unique triangular shape, mirroring glass facades clad over an exposed wooden frame. This garage promotes both environmental and social sustainability and has become a beacon of the city's sustainability ambitions. Tangbom Architects tried to make the neighbourhood safer while reinforcing Uppsala's status as a bicycle community by combining practicality with a distinctive design concept. The 2 floors are connected by a wooden ramp, making it possible to ride the bikes between floors. CASANOVA project of K-Render has been nominated for Best Rendering of the Year 2021. There are 3 factors that you need to pay attention to. The light. The lighting in CASANOVA's rendering is focused on the walls where the tiles are displayed. The light makes the wall and the product hanging on it look like a painting. Materials. The materials look almost exactly like they are in real life. The color of each tile is meticulously rendered. From color to pattern, every little detail of the tile is very realistic. Rendering angle. To best express the spirit of the design, the rendering angle is also important. For each area, the artist will use the appropriate camera angle to reveal their beauty. In Casanova's renderings, the artist mostly used horizontal render angles. This will give the viewer an overview of the entire object in a narrow space.